Good morning. Before we get started on our new lesson today, I want to do some review from yesterday. The diagram below shows different density layers of the Earth. There are 4 layers of the Earth. Put these 4 layers in the correct order. Number 1 is the crust. This is the thinnest layer, the uppermost layer of the Earth where we live. The crust is broken up into different pieces called tectonic plates that we will learn about tomorrow. The crust has the lowest pressure, temperature, and density because there are no other layers on top of it. Number 2 is the mantle. This is the thickest layer of the Earth that contains molten magma, which churns in convection currents that's powered by the heat from the core. Number 3 is the outer core. This contains liquid iron that also circulates. This circulating motion of the liquid iron generates what we're going to discuss today, the Earth's magnetic field. And finally, number 4 is the inner core. This is a solid, giant ball of iron. At the inner core, temperature, pressure, and density are all extremely high. So to review, what layer of the Earth is the thinnest? What layer of the Earth is the thickest? As you travel from the outside of the Earth to the inside, the temperature does this and the pressure does this. Great. We're now ready for today's topic, which is magnets. You should be on page 13 of your notebook. Your objective today is, I can explain where the Earth's magnetic field is the strongest and discuss why it exists. So Earth's magnetic field is your first topic for the left side of your notes. Earth's magnetic field behaves as if the planet has a giant bar magnet inside of it, like the picture to the left. Just like a bar magnet, the Earth has 2 poles, a north and a south pole. However, the geographic north that we call the North Pole is actually magnetic south. How can we detect magnetic fields? How do we know this magnetic field exists? Well, not only have scientists studied the composition of the inner core and outer core and recognized that the moving iron generates a magnetic field. On the surface of the Earth, as just average citizens, we can pick up on the magnetic field using a compass. A compass is a simple tool that becomes magnetized when it's rubbed with a magnet. And once this happens, it will then align to the magnetic poles so that we can witness the magnetic field of the Earth. So let's watch quickly how you can make a magnet at home. main point in that video is that the man magnetized the needle by stroking it with a magnet. This allows the needle to pick up on the magnetic field of the Earth. So back to our notes. Where are the strongest forces of the Earth's magnetic field? They're found at the poles, both the north and the south poles of the Earth. This is where the lines are closest together. The lines are just drawn to represent the magnetic field. They are invisible, but the force is very much present. So right here at the top of our Earth and at the bottom is where the field is going to be felt the strongest. Now remember, even though this is what we call the North Pole geographically, it's really the South Pole of the magnetic field. So you'll notice that the field starts down at the North Magnetic Pole and goes back in at the South Magnetic Pole. Why is the outer core important? We covered this yesterday. Convection of the liquid iron in the outer core, plus the fact that the Earth rotates around itself, is what produces this magnetic field.